Every animal on Earth eats its food raw. The lion tears into a fresh kill. The wolf does the same. Even chimpanzees, the closest living relatives we have, spend up to 6 hours a day just chewing. Not eating, chewing. Grinding tough fiber and raw meat into something their bodies can finally use. Humans don't do that. We are the only species on this planet that changed its food before it changed us. And that single decision, made by a hungry ancestor, standing near a flame almost 2 million years ago, did something no dietary choice has ever done before or since. It rewired the human body from the inside out. It shrank our gut, exploded the size of our brain, reshaped our skull, cut our sleep in half, and built the very foundation of human society around a burning fire. If that ancestor had never picked up that scrap of burnt meat, stop. You would not be sitting here watching this. You would be somewhere in a forest, chewing raw roots for 8 hours a day, with a brain a third the size of the one you're using right now. So today we're asking the question almost nobody actually answers properly. Why did ancient humans start cooking food? Not the easy version, it tasted better. The real version. The biological chain reaction that turned a scavenging ape into the dominant species on Earth. Let's start with the world before fire. Because you cannot understand what cooking solved until you understand how brutal the raw food problem actually was. Pre-fire humans were eating exactly what other great apes eat. Raw meat, raw tubers, raw leaves, raw fruit, raw nuts. And that diet came with a hidden tax that most people never think about: time and machinery. A chimpanzee spends roughly 6 hours of every single day just chewing because raw food fights back. The fiber resists. The cell walls hold their nutrients hostage. Muscle tissue is tough and stringy. None of it gives up its calories easily. To survive on that diet, early hominins needed enormous jaws, massive chewing muscles anchored to the skull, and a long, expensive digestive tract built to slowly break down everything the teeth couldn't. Look at the skulls of early Homo species, and you can see it directly. Heavy brow ridges, wide flaring cheekbones, huge attachment points for muscles that don't exist in the same way on your face today. The gut, meanwhile, was a factory running around the clock, and factories cost energy just to keep the lights on. This is the world fire walked into. And what fire actually does to food is where the real story starts. Heat is not just a flavor enhancer. It is external digestion. When you cook meat, the proteins unfold and denature, turning something dense and difficult into something your enzymes can break apart almost instantly. When you cook a tuber or a root, heat shatters the starch structure. Converting it into glucose, your body can absorb in minutes instead of hours. Cooking even kills a huge share of the bacteria and parasites riding along on raw food, which meant fewer ancient humans dying from something as simple as a bad piece of meat. Anthropologist Richard Wrangham, who built the most complete version of what's now called the cooking hypothesis, estimates that cooked meat delivers roughly 30% more usable energy than the same raw meat. Cooked starchy vegetables do even better. Same food, same weight, dramatically more fuel. That single fact is the hinge the entire story swings on. Now here's where it gets interesting. Because more energy from less food doesn't just mean a fuller stomach. It means the body can afford to change its own architecture. If fire is doing part of the digestive work outside the body no longer needs such an enormous, expensive gut to do it internally. And that is exactly what happened. The human gut is roughly 60% the size you'd expect for a great ape, our size eating a typical raw diet. That is not a small shift. That is one of the most significant anatomical changes in our entire evolutionary history. And a smaller gut means something else. Something almost nobody connects properly. It means freed up energy. The gut is one of the most metabolically expensive tissues in the entire body, second only to the brain itself. Shrink one expensive organ, and you free up a metabolic budget that has to go somewhere. It went to the brain. This is the expensive tissues hypothesis, first proposed by researchers Leslie Aiello and Peter Wheeler, and it might be the single most underrated idea in human evolution. The brain consumes roughly 20% of your total daily energy, while making up only about 2% of your body weight. Running a brain that large while also running a gut built for raw food would be metabolically impossible on the food available to ancient humans. Something had to give. The gut gave. The brain grew. And the fossil record backs this up almost too neatly. Homo erectus appears roughly 9 million years ago, with a noticeably larger brain than everything that came before it, right around the same window, where we start seeing the earliest suspected evidence of controlled fire use and changes in tooth wear and jaw structure, consistent with a softer, cooked diet. Correlation isn't proof, but the biological logic lines up with the timeline in a way that's very hard to dismiss as coincidence. Now let's talk about your face, because cooking didn't just shrink your gut, it rebuilt your skull. Cooked food is soft. It takes far less force to break down than raw food, which means the massive jaw muscles, the heavy brow ridges, the wide cheekbones built for grinding, none of it was necessary anymore. Generation after generation, the jaw shrank. The teeth shrank. The canines, once used for both processing tough food and displaying dominance, retreated until they barely rise above the rest of your teeth at all. And here's the part that should genuinely stop you. That shrinking jaw freed up physical space inside the skull. Less room needed for muscle anchor points meant more room for the brain case to expand. Your smaller jaw and your larger brain aren't two separate coincidences. They're two ends of the same trade, negotiated inside your own skull over 1 million years, because your ancestors started putting food near fire. By the way, if this is the kind of thing that fascinates you, the hidden mechanics behind why the human body looks and works the way it does, that's the entire reason this channel exists. Hit subscribe and stick around, because we go this deep into human evolution every single week. Cooking also bought ancient humans something almost nobody talks about: time. 6 hours of chewing a day is 6 hours. You cannot spend doing anything else. No tool making, no teaching, no extended social bonding, nothing. Cooked food is fast to eat and fast to digest. Modern humans spend roughly 1 hour a day chewing, a saving of nearly 5 hours compared to our ape relatives. 5 hours a day, every day, for hundreds of thousands of years, redirected into tool refinement, cooperative hunting, teaching the next generation, and the kind of complex social behavior that raw food simply doesn't leave room for. It didn't stop at daylight either. Digesting raw food is a metabolically loud process that keeps the gut working hard well into the night, disrupting deep sleep. Cooked food digests faster and quieter, which is part of why humans sleep roughly 7 to 8 hours a night compared to 9 or 10 for chimpanzees, while still getting more of the deep, restorative sleep that repairs the body and consolidates memory. Less time chewing, less time sleeping, more time left over to become something new, and that surplus time gathered around one place. The fire itself, a fire needs tending. It needs fuel, protection from wind and rain, and someone willing to keep it alive through the night. That single requirement created something raw foraging never demanded, a fixed gathering point. The hearth. Anthropologist. Polly Wiesner studied modern hunter-gatherer groups and found something remarkable. Daytime conversation revolved around practical, transactional matters, while nighttime conversation around the fire shifted almost entirely towards storytelling, social bonding, and cultural knowledge passed down through generations. The fire wasn't just cooking dinner. It was building culture, one evening at a time. It likely built something else too. Cooked food sitting at a hearth is a resource that can be stolen, unlike fruit picked and eaten alone in a tree. That created a need for defense, for sharing rules, for trust between specific individuals. Some researchers argue this is one of the earliest roots of the human pair bond itself, a partnership built around protecting and sharing cooked food long before anything resembling modern relationships existed. So, when did all of this actually begin? Here's the honest answer. We don't fully know. The earliest solid evidence of controlled fire use comes from Wonderwork Cave in South Africa, dated to roughly 1 million years ago, with more debated traces. Reaching back even further, confirming cooking specifically, rather than just fire use, is much harder, archaeologically, because the evidence it leaves behind is far more ambiguous than burnt stone or ash layers. What we do know is this. The first cooked meal almost certainly wasn't a deliberate invention. It was an accident. Meat left too close to a wildfire, discovered afterward to be softer, safer, and strangely satisfying. Nobody planned the biological cascade that followed. Nobody could have. But that accidental discovery is written into every part of you today. Into the size of your brain. Into the shape of your jaw. Into the hours you sleep and the hours you don't spend chewing. Into the reason humans gather around tables and fires and shared meals in the first place. You are, in the most literal biological sense, a cooked food animal. Your body was rebuilt around fire, one generation at a time, until it could no longer function properly without it. The next time you turn on a stove, you're not just making dinner. You're repeating the exact act that built the modern human brain. What do you think? Was cooking humanity's greatest accidental invention? Let me know in the comments, and I'll see you in the next one.